Welcome back. In the last few lectures, we discussed some of the basic concepts of propositional logic. So why we have discussed about propositional logic is that modal logic is considered to be an extension of propositional classical logic. Classical logic, I mean propositional and predicate logic. But for this course, since it is considered to be an introductory course, so we are focusing our attention on only modal propositional logic. That too, normal modal propositional logic is the one which is of interest to us in this course. So today I will be talking about some of the limitations of classical logic, and we need to know about some of the limitations of classical logic before getting into the modal logic. So there are certain things which classical logic fails to explain. So classical logic works as long as mathematical reasoning is concerned, it works perfectly alright, but when it comes to day-to-day reasoning, it has some issues. So that is what we are going to discuss in this lecture. So before I begin, let me quote from a famous logician. Is considered to be the founder of fuzzy logics. Fuzzy logic is considered to be an extension of classical logic. It is also considered to be deviant logic. So he is of the view that doing classical logic is like a person who comes to the party dressed in a black suit, a white and starched shirt, a black tie, shiny shoes, and so on and so forth. We will be giving a lot of importance to the formal dress in particular. Doing fuzzy logic in the same sense, it applies to our context as well, non-classical logics like modal logics, etc. It is like a person, that is what we will be interested in. It is like a person dressed informally in jeans, t-shirts, sneakers, and so on and so forth. So that is what we prefer over the formal dress in many such kind of occasions. So in the past, that is before the development of these logics, fuzzy logic, etc., Jade is of the view that this informal dress, that is informal dress, won't have been acceptable. But today it turns out to be the case that it is considered to be the reality. So classical logic obeys some kinds of laws, all the laws of logic like law of identity, law of excluded middle, law of non-contradiction it obeys, and then it is also considered to be monotonic. But in our ordinary day-to-day reasoning is considered to be non-monotonic in nature, and there are some of the there are some fundamental laws of logic which fails in the case of classical logic. This is what we have been discussing so far. First of all, logic is considered to be a systematic study of argumentation, and it is concerned with the principles of valid reasoning. It is not just enough that you reason, but you need to have valid principles of reasoning. And classical logic, I mean first order logic, which includes propositional and predicate logic, are considered to be the starting point for the study of reasoning. You need to note that reasoning is a very big domain, but our starting point is the classical logics, that is considered to be propositional and predicate logics, and it is appropriate for mathematical reasoning, and it is also considered to be bivalent, monotonic, and it is based on the problematic, the one which we are going to talk about in a while from now, the problematic material implication. And classical logic is not appropriate for formalizing human reasoning. Why it is the case that it is not appropriate? That is what you are going to see in this lecture. There are three reasons at least for why classical logic fails, particularly in capturing human reasoning. It is because of this that classical logic is considered to be monotonic, and in many situations we have to come up with some kind of arguments which are considered to be non-monotonic in nature. For example, all birds flies, Tweety is a bird, and from that you immediately come to the conclusion that Tweety flies. So but you came to know from some evidential source that Tweety comes under the category of birds, but it doesn't fly. So then you need to withdraw your conclusions that you have derived earlier. But classical logic will not permit us to withdraw the conclusions that you have derived earlier. So you need to be non-monotonic to understand such kind of reasoning. So which comes under the category of non-monotonic and default reasoning. The second reason why we classical logic fails is that when it comes to reasoning, we reason based on incomplete information. No matter how much information we have, is always be incomplete, and we need to reason under uncertainty. All these cases you will not be able to explain it in the case of classical logic. There is another reason why we need to move away from the classical logic. The reason is that we need to incorporate vague predicates. So vague predicates are considered to be part and parcel of our logics. Then you need to come up with another way of defining the implication. Material implication will not work there, so you need to come up with another kind of implication. But for us, the most important reason why we will be interested in moving away from the classical logic is that in modal logics in particular, that is of interest to us. So there is no way in which you can distinguish, especially in the case of classical logic, there is no way you can distinguish between something is actually the case, that is we are writing it as P, something which is possibly P, which is we are writing it as diamond P, and something which is necessarily the case, that you are writing it as box P. So there is no way in which you can distinguish between these two things, three things. So in classical logic, everything is same, that is you just simply write it as P. So there is no distinction between it could have been the case, it might have been the case that P, or it is necessarily the case that P. Comparing, if you compare it with what we come across in the classical logic, that is simply something is actually the case that P. So these are some of the basic principles of logic that all of us are aware of it. Law of identity, P is P. Law of excluded middle, which tells us that either P is the case or not P is the case. One excludes the other possibility, and sometimes this R can be used in inclusive sense and exclusive sense. If I don't mention it right up or something like this, then we take it as inclusive R. Otherwise, based on the circumstance, we need to view it as exclusive R. Suppose if you say salad, fruit salad or ice cream, then you are not supposed to take both of them, but you are supposed to take either salad. If you take salad, automatically it will restrict you to take ice cream. In that sense, we are using it in the exclusive R kind of. So law of excluded means one excludes the other possibility. And law of contradiction is that simultaneously a statement cannot be both true and both false. P and not P cannot be the case at the same time in the same sense. A contradiction occurs when one statement excludes the other the possibility of another, but yet both are claimed to be true. So sometimes truth may not be self contradictory. So these now the immediate question that comes to our attention is that are all these laws complete? But the situation is that a variety of arguments can easily be produced to show that these laws are considered to be incomplete. So they do not specify all reality. As a matter of fact, it refers to parts of reality. Parts of reality can be shown to be contradicting one another of these Aristotelian laws that we have seen: the law of identity, law of excluded middle, and law of non-contradiction. So it is an interesting problem, right? Is there right from the Greek period onwards? It is considered to be the problem of change. So it is Heraclitus pointed out that for anything to change, it must turn into something else. If it is not turning into something else, you are not set to, things are not set to have changed at all. And then he asked this question: how a thing could be same thing? How a thing could be something other than itself if it does not, if it involves some kind of change? So with this view, he has come up with a famous phrase, and this is quite popular. That is this thing: you cannot step into the same river twice. Once you step into the river and the water flows, and then next time when you step in, it is not the same river, a different flow of water, you will observe it. So now if Aristotle's laws are taken to be all the fundamental laws of logic, that is law of identity, law of excluded middle, law of non-contradiction, then logically speaking there can be no change possible whatsoever, because change negates all the three laws. Why it negates all the three laws? From Heraclitus' point of view, if something is A is changing into something else, this A is turning into A prime or A star or something like that. So which is quite different from what is the case earlier, what was the case earlier. So that means either change does not exist, or it becomes totally illogical, that because all our laws of logic fails. So for example, if A changes to A star, then A is not equivalent to A. In the same way, if law of identity fails, law of excluded remedial automatically fails, because you can always have A or not A prime, something like this, where it will not, law of excluded remedial will not hold. And law of contradiction also fails. Law of non-contradiction also fails. So now, since all measurements, detections, thoughts, perceptions, etc. are simply considered to be changes, then it follows that these operations logically cannot exist. Why? Because if you want to talk about change in logical terms, these fundamental laws of logic cannot capture it, and if you do talk about laws of change, if you do talk about change in terms of laws of logic, it is going to be illogical. So now the question is that how do we resolve this particular kind of paradox? This is also considered to be a paradox, which is called popularly known to be motion paradox. Whether motion is possible at all. Motion requires some kind of change from one position to another position. So Aristotle's three laws must specify or apply to only that which is not changing, or static objects. Since any kind of change violates all the three laws that we have seen earlier, there is law of identity, law of excluded remedial, and law of non-contradiction. If at all change exists, logically exists, and there must exist at least another kind of law which is quite popular these days, it is considered to be fourth law of logic. We need to explicitly state that one if all the three laws fails. So one which applies to whenever you have some kind of change which is there. So the fourth law must contain the negation of all the three laws, since change negates all the three laws, because A is converting into A star and then A is not equivalent to A, law of identity fails, law of excluded remedial also fails, and it need not be law of non-contradiction also fails. So that means you need to have a fourth law to explain the change. So to be consistent in any particular logical case, either the three laws, law of identity, law of excluded remedial, law of non-contradiction explicitly apply, or the fourth law explicitly applies. If the fourth law explicitly applies, all the three laws are automatically implicitly assumed to be false, and if these three laws are explicitly assumed to be the case, then the fourth law is assumed to be implicitly false. So either the change explicitly exists in that particular case, or it does not. Since all four laws must apply at all times, when the fourth law applies explicitly, it is automatically assumed that the three laws must be implicit. So from this what we get is that laws, these three are considered to be the fundamental basic laws of logic: law of identity, law of excluded remedial, and law of non-contradiction. And based on that we have this classical logic, that is propositional and predicate logic. So now how do we explain motion, etc., dynamic features like motion, etc., by using these three laws of logic? So classical logic fails to provide a satisfactory account of the following things apart from the change, etc. These are the things that are of interest to us. It fails to account for proper analysis of conditionals. There are many different kind of conditionals which cannot be defined just by means of material implication, like counterfactual arguments, subjunctive conditionals, etc., or conditionals with future condition in which it has an antecedent which is referring to the future, or future contingent sentence. So these are problematic kind of things. So arguments involving possibility, because in classical logic there is no distinction between possibility of P and P. So we always make this distinction that we don't know what is happening outside in this from this room. So we always we can say that it is possible that it is humid outside, or it is possible that it is raining outside. So it is possible that it is raining outside doesn't imply that it is actually raining there. But if you take classical logic into consideration, it is possible that P is same as it is actually the case that P. When it comes to necessity, possibility, actuality, there is no distinction in classical logic. So we need to make such kind of distinction. And when it comes to logic of knowledge and belief, we have separate kind of we have different kinds of modal logics to take care of this logic of knowledge and belief. These are called epistemic logics. And when it comes to vagueness, classical logic completely fails. Vagueness is not a part and parcel of classical logic. But if you want to live with the vagueness, etc., then classical logic has no answer. It has answers, but it may not be appropriate if you follow just two-valued logic, because any kind of vagueness involves a kind of boundary line. Suppose if you take examples of classical logic, it is clear that they will be considering only cases like mortal, non-mortal. You can clearly draw a line between what is considered to be mortal, what is considered to be non-mortal, like donkeys, cats, etc. You can easily draw a line. What is considered to be donkey, what is considered to be not donkey. But in many situations in day-to-day reasoning, it cannot be the case that you can draw a clear line between what is the case and what is not the case. When it comes to any kind of vague predicate like rich, poor, all these kinds of vague predicates, baldness, etc. For example, if you take a simple example of rich, somebody who is having billions of rupees is considered to be automatically considered to be rich. A person who is considered to be bankrupt, a beggar, not having any money in any bank or anywhere else, is considered to be poor. But there are some other kinds of people who fall under this particular kind. They're definitely not rich, definitely not poor. So they can be called upper middle class, middle class, lower middle class, etc. All these things are gradations of a kind of truth. So each sentence comes up with a degree of truth there. So if you want to have such particular kind of thing, then we need to move away from the classical logic. We need to we need to give up this law of excluded middle, and we need to allow for many values. So non-classical logics are developed to overcome several such defects which you find it in the classical logic. One such kind of thing is the modal logic. In the modal logic, we take care of a particular kind of thing where you will be able to distinguish between possibility of P, necessity of P, and what is considered to be actually the case at P. So that is of interest to us. We will be dealing with other kinds of examples also in this lecture. Classical logic obeys transitivity, A plus B, B plus C, and A plus C, and property of bivalence. It has only two values, and it is considered to be monotonic. That means addition of new information will not, you will not be addition of new information will not cause you to withdraw the conclusions that you have derived earlier. In common sense reasoning, the reasoning that we employ in our day-to-day reasoning is considered to be non-monotonic in nature. So classical logic fails in these cases. So there are two reasons for doing non-classical logic. There are many reasons, of course. Classical logic is of no help to represent intentional concepts. That means those concepts which involves modes of truth. That means a sentence can be true in different ways. For example, if you say X is happy, it is different from X is believed to be happy, X is thinking that he is happy, X is known to be X knows that he is happy, etc. They are all different things. They are different modes of truth. In the same way, whenever you are referring to temporal kind of concepts, something which is always true, something which is true in the past, something which is going to be true in the future. So you need to have these modalities, intentional concepts like this. So the difference between intention and extension, which we will be talking about it in the next few lectures, but in a nutshell, if the truth value of any proposition or any formula is solely determined by the truth value of its constituents, then it is considered to be extensional. It is in that sense classical logics are considered to be extensional in nature. So for example, if you have P or Q, if you know the truth value of P, if you know the truth value of Q, you will automatically come to know the truth value of P or Q. And you need to note that human knowledge also be considered to be incomplete, and most of the time you have to tolerate inconsistencies of the global level and the local level. there's a certain inconsistency at the global level you can still tolerate, but at the local level you may not be able to tolerate it, or maybe the other way around. So classical logic cannot express incomplete, inconsistent information, because there are, you need to be you have to invoke the non-monotonicity property there, and it fails to explain vagueness, which is considered to be the part and parcel of our life. So non-classical logics, there are some of the examples of non-classical logics, but we will be focusing our attention on modal logics. Modal logics include tense logic, the logic of time, I mean where something which is always the case, something which is sometimes it was true in the past, and something which is actually true now. These are different, represented as some kind of modalities. Something is necessarily true in the context of temporal logic, particularly in the sense that it is always true in the past, present, and even in future. And there are some logics such as doxastic logics. Deontic logic talks about logic of obligations, etc., morality, issues relating to morality, dynamic logic, conditional logic, and intentional logic. So we will be dealing with elliptic modal logics. That means modal logics which includes possibility and necessity in general. So when we talk about necessity, we are talking about logical necessity. So this I will discuss it in greater detail when I talk about possible worlds. It is a technical notion, possible worlds. I will be talking about it in greater detail. So there are this is the thing which we will be doing in this course, but there is another way in which other direction in which you can go ahead. So that is deviant logic. In the deviant logic, what you do is these are some of the fundamental laws of logic that we have seen earlier: law of identity, law of excluded middle, law of non-contradiction. And situation arises in such a way that you need to give up one of these fundamental laws of logic. You need to withdraw that kind of thing. So then you are deviating from the classical logic, and these are considered to be deviant logics. So intuitionistic logic, for instance, for example, in this case, suppose if you are not able to prove P and you are not able to prove not P also, then P or not P cannot be true there. So when you are referring to the proof and you are not able to produce proof for P, you are not able to produce proof for not P, so that's why P or not P doesn't hold there. In the case of paraconsistent logic, it allows for some kind of inconsistencies, like this thing. Law of non-contradiction fails there. Law of non-contradiction states that it cannot be the case that a sentence can be both true and both false. But you can have an example. There are many examples which you can have. One example could be like this: that a person standing at the doorstep with one step in and one step out. So now if you ask ourselves whether he is in, of course he is in; he is out, of course he is out, etc. So you have more than two truth values. A sentence can be both true and both false also. He is not in and he is in also. So when you allow for degrees of truth of a sentence, in classical logic, every sentence is considered to be either 100% true or everything is certain there. So if you say all men are mortal, Socrates is man, Socrates is mortal, there is no way in which Socrates is mortal, that is a conclusion which follows from all men are mortal, Socrates is man, with 90%, 70%, etc. So if premises are true, it leads to, I mean, your conclusion cannot be false. Conclusion necessarily follows from the premises. That is what is deductive reasoning is all about, and classical logic is deductive in nature, propositional and predicate logic. So in the many valued logic, you will allow for many truth values, and for example, if you allow for more than two truth values, then you are talking about three valued logic. And when you allow for many values, that means you are invoking degrees of truth of a sentence, then it is considered to be multivalued logic, and one instance of multivalued logic is fuzzy logic. So I will end this lecture with a simple remark that classical logic works in many cases, and classical logics, I mean propositional and predicate logic, is definitely a very good starting point, and we need to have this starting point. That's the reason why I came up with this. I came up with a few lectures based on a crash course on classical logic. So we need to know where we are deviating and we need to know where we are extending the classical logic. In the next lecture I will be talking about some of the historical origins of classical logic, and before that I will be talking about some examples where classical logic fails. For example, Socrates paradox, and some examples relating to particularly the distinction between necessity of P, possibility of P, and actually the P. And what interests us is some paradoxes. For example, sentences like this sentence is false. If that sentence is neither true nor false, so how can we incorporate liar sentences into our language? So these are the things which trigger us to move away from the classical logic and either to extend it or deviate from the classical logic. But in our course we are only extending the classical logic by adding few more operators. These are considered to be unary operators, which stands for possibility and necessity. Thank you.